Hello. In this video, I'm going to demonstrate you some of the bitwise operations. Let us create a project first. I'll call it as using bitwise operators. Create a class to run a program. Let's add a main and declare a couple of variables. Let's declare int num1, num2. Now let's give some value to num1. Let's say it is 65. And then we will use an operator called as a shift operator to see what happens. So let's say sysout equals to sysout num1 two less than symbols and 1. And first we'll understand what's happening, or we'll see what is happening, and then we'll try to understand what's going on there. So I'll execute as Java application, and it gives me a number 130. Now how did this happen? Now the operator less than is called a left shift operator. Basically, it is going to shift the bits within this num1 by 1 unit and then generates the equivalent and then prints that value. So that is 130. Now num1 is as it is, but during the expressions evaluation, the shift happened. Now to understand this better, I have created an Excel file here to explain what is going to happen. First, let us consider this number 65. Now 65 when converted into binary is where you have 1 followed by 5 zeros and then you have 1. So you can see the position, the bit number 7 is 64 and bit number 1 is 1 and 64 plus 1 is 65. So I have given here an indication that it is 65. Okay, so that is 65 there. What happens when you do a shift towards the left side is that the position 7 is moved to position 8 and the value in this position 1 is moved to value in position 2. And the empty space is going to be filled in with zeros, which means the 1 here gets shifted to 1 here and then this becomes 0 and then here becomes 1 and this is 0. Now as you can see, the value at that position is 128 and value at this position is 2. 128 plus 2 is 130. Now that's what happened. Now the same way I can do also something like 65 pushed by 3 bits. Now if you check this Excel, this was 65, 1 and these two were 0, so that's 65. Now each of these are moved by 3 bits. That means one time, second time, third time. So this is going to be 1 and of course that was moved, and this is going to be moved one time, second time, third time, and this is going to be 0. So as you can see, 512 plus 8 is 520. Now let's execute and verify, and there you go, it is 520. So that is how the shift operators are working. Now that it is 520, if I move it back 2 bits, so you should see that the result will be, that's going to be 1 here and then 1 here. Of course, these values become zeros because they have been moved now. And that's 128 plus 2, 130 again. So if I have taken 520 and then shift on the right side by 2 bits, the result should be 130. So I'll execute this. You can see it is 130. So what happens if I push this 2 more times? As you can see, the bit at position 8 is moved to bit at position 6, and here this is going to be evicted from the byte. So if I'm taking a value here, so let's say for example 1 and this becomes 0. Now you can see it just remains 32. So the leading bit which has gone, it is gone. So I can now say it is 130, shift by 2 will result in 32. As you can see, that is the result here. Now The same way, I can also work with bitwise and bitwise OR. So to understand this, since in the Excel I'm only considering 16 bits, that's equivalent to 2 bytes, let's declare a short instead of int. So I'll say short num1 and num2. If I want to store the result, I can do that. However, I'll just perform the operations directly. Now let's consider num1 to be around, let's say 64 and num2 to be 32. Now I'm just taking these numbers so that it becomes easy for us to calculate. So I'll perform an operation num1 ampersand num2. Now, very importantly, you should observe that it is a single ampersand and not double ampersand. Now, remember, double ampersand corresponds to AND, logical AND, but this is a bitwise AND. Now, what happens here is, let's check this with an example. I'll go with another sheet here where I've got lined up some more digits. Now, this is the digits in the first number, num1, and these are the bits in the second one. Now, since I took 64 and 32, so technically this is 1 and this is 1 here. So this is 0, 0, 0 and so many zeros followed by 1 followed by 6 zeros is 32 and 1 followed by 5 zeros, sorry, 1 followed by 6 zeros is 64 and 1 followed by 5 zeros is 32. Now the way AND works is, now if you have a bit in a specific location as 1 and 0, it's more like if both of them are 0, it is 0. If any one of them is 0, it is 0. But if both of them are 1s, then it's going to be 1. For example, if I had taken a number like 64 plus 32, that's going to be like 96 in a second number, then you can see that 1 and 1 is equals to 1, but 0 and 1 is 0. So the result is going to be 64. So if we go and check this out as it is 64 and 32, the result you should see as 0 because there is no coinciding ones in the respective bits. But if I go and make this as 96, now you will see that the result is going to be 64, and that's because of this particular calculation. So in case if I have 120, let's say 65 and 97, then you will see that it's going to be 65. So if I have here 65 and 97, it's going to be 65. So the bits in respective positions, if they are ones, then it's going to use an AND of those. So it is equivalent to 1 and 1 is 1, 0 and 1 is 0, 0 and 0 is 0, 1 and 0 is also 0. So the only way 1 and the result is going to be 1 is when both the digits are both the bits are in the same location, they correspond to 1. Now similarly, you can also look at an OR operator. Now if I'm going to do the OR of these, so let's just figure out first. The OR is done using a single OR or pipe symbol. Now notice that double pipe symbol would represent a logical OR, but this is not a logical, this is a bitwise. So if I execute this, you can see that it says 97. Let's see why. We go back to another sheet here where a similar structure I've kept. One is 64 and 65 now. That's the first one. The second one is a 97. Now 97 is because of 64 plus 32 plus 1. As you can see, 0 or 1 is also 0. 1 or 1 is also 1. 1 or 1 is 1. Now, if I just happen to put a 1 here, that is going to be plus 4 to the first number, that's 69. So if I go back to this and put 69, you will see that the result is 101, which is what we see here, 101. So this is exactly how this AND and OR works. You also have another operation that can be performed, which is NOT. A NOT is done using a tilde. For example, let's put this number 1. Let me just get rid of all this. Let's put only short num1 equals to 65. And if I just print sys out num1, that is 65. Whereas if I use a tilde, that is considered as a logical or rather bitwise NOT. That means it is going to complement the bits in each of this. Now, at this time, it is important for you to understand what is the use of a leading bit. Now here, for example, let's go back to this example where I have kept the bit 16 is a reserved one. I'm not using that as a value, but I'm just printing here, is it a plus or a minus? So if this is supposed to be 1, then it's going to be representing as -1, basically the negative sign. Now let's ignore this particular side and let's say we have 65. Now 65 is done by typing 1 followed by 5 zeros and then 1. So this is our 65. As of now, it is 65 and that is our num1. But if I'm using a tilde num1, it's just going to complement all zeros to ones and ones to zeros, including the bit that represents the sign. So which means we're going to convert this into ones, and then this is going to be 0, and this is all going to be 1, and this is going to be 0. Now, if you try to check this result now this result is not what we are expecting. Now, the reason is that when it is a negative sign, it is going to perform something called 2's complement. In 2's complement, it is going to convert each of these ones into zeros and zeros into ones and adds an additional 1, and if that overflows, it is just going to be carried forward to the next location, which means we're going to take this one. Okay, note that this all is this going to be complemented plus an additional 1 is added over here. That's the 2's complement. So I'm going to bring this back to zeros, and then this is going to be 1, and this is going to be 0 again, and this is going to be 1. That is after complementing. But by adding a 1, now it is like 1 plus 1 is equal to 2. So that 2 is going to overflow to this particular digit, which is like 1, 0 is 2. So that's the way it is going to work. And as you can see, the result is going to be minus 67. Now let's just check this out in our result. Now yeah, I'm sorry that there was a mistake because this is 1 0. After adding, it is supposed to be 1 0, and that happens to be 66 here, not 67. And that's just is going to the way this is going to work.